Hello everybody, today I'm excited to share with you my latest project, a 1 mega flash ROM for my Z80 computer. This project pushes the boundaries of what my Z80 setup can do, and I can't wait to walk you through how it all came together. The core of this flash ROM is built using two AT29C040 chips, which provide the capacity to save and read data directly from the Z80 computer. Together, these chips form the backbone of our 1 MB storage system. To make this work, I designed a system using several components. One 8-bit registers to save control signals. This included 3 bits to select the address chip, 1 bit to read data, and 1 bit to write data. 3 8-bit registers to set the 20-bit address for the flash ROM split into 8 bits, 8 bits, and 4 bits. An 8-bit buffer to read data from the flash ROM, another 8-bit register to write data to the flash ROM, finally some OR and NOT gates handle the control signals for smooth operation. Once the design was ready, I moved on to creating the schematics and building a prototype on a breadboard. I wanted to share some key technical details about using the AT29C040 flash ROM chips. Reading data is pretty straightforward. You just need to send a 20-bit address to the chip and read the value stored in that location. However, writing data is a bit more involved because the chip has a built-in software protection mechanism. To enable writing, you need to follow a specific sequence of commands. Here is how it works. First, you write the value AA to address 5555. Next, you load the value 55 to address 2AAA. Finally, you write A0 back to address 5555. Once you've completed this sequence, the chip is ready to accept data to be written. Now, here's another important detail. Each flash ROM is divided into 2048 sectors, with each sector holding 256 bytes of data. If you want to modify even a single byte of data in a sector, you will need to rewrite all 256 bytes for that sector. And here's the result, a functional system loading an image onto the screen.
I'm a hustler, status, only luck free. Berry, now this is my style. Playing broken games all night, who's the night? Caught the king of sickness, toxic but I'm not the patient. Giddy fight on machines, a condom, cut us, kitty back, come on, sounds and the gimmick. You can make a suicide and talk it time, baby. No matter no matter I still can't go. 誰も彼も汚れて見えてあれもこれも全て壊れて見えて We can go We can go.
With the prototype working, I designed the PCB in KiCad, translating the breadboard layout into a more permanent solution. Here is a look at the PCB design in KiCad. After finalizing the design, I ordered the PCB. Once it arrived, I got to work soldering the component onto it. Here is a glimpse of the process. And now the moment of truth. I loaded 32 images, each around 30 kilobytes, into the 1 mega flash ROM. Then I displayed them rapidly on the screen, creating an animation effect. Check this out. This project showcases the potential of combining modern storage solutions with retro computing. If you are as passionate about retro tech as I am, I'd love to hear your thoughts in the comments below. Don't forget to like, subscribe, and stay tuned for more projects to come. Thanks for watching.